you ever wondered what makes one kind of soccer ball, golf ball, or football fly through the air better than another one?
What we're trying to do is study different types of plastics and how they could be used in different types of sporting materials.
Oh, see? I'm safe.
This is a piece of silly putty. So it has some properties that make it like a solid, but it also has properties that make it like a liquid. What do you think would happen if you took an ice cube and you hit it with a hammer? But could you take an ice cube and form it into a ball and have it be a nice rubbery ball that bounces and then stretch it out? The challenge of material science is to try to make materials that are more lightweight and stronger than materials that are currently used.
So the more cross-linker I add, the stiffer the material becomes. It's almost between a rubber and a gel.
What kinds of things can you think of where we can use all of these different tools that we have as scientists in order to make new materials for sporting goods?
When you hit a drum or play any musical instrument, you're making the instrument vibrate. And it's this vibration that we hear as a sound in all the musical instruments we play.
When you think of musical instruments, you usually think of something like a piano or a banjo or something. But it is possible to make a musical instrument that isn't like any other musical instrument you ever saw before.
You can make a musical instrument from almost anything that makes a sound.
You could see a musical instrument as just a machine for sending vibrations out into the air.
Vibrating means moving back and forth very quickly, right?
So quickly that you can hardly even tell it's happening. You can't see it with your eyes, but you can hear it with your ear. Your ear can tell the difference between a fast vibration and a slow vibration.
And the faster the vibration, the higher the note we'll hear.
That's exactly right.
A microorganism is a very small organism. That's why we call it micro. You can find them everywhere. In this little handful of dirt, there would be billions.
So what we did in this experiment is we took a swab or a Q-tip. It's like this. And then we rubbed it on common places. We used a doorknob, and we also used the handle on the toilet in a boy's bathroom. And here are all the colonies here, and they're actually even more than what we found on the doorknob, which shows that bathrooms are very dirty.
Bacteria is found everywhere, even in places where you wouldn't expect.
Most of the bacteria are natural inhabitants of the earth, and they're very beneficial.
They're even found in our skin and inside our intestines.
That help you digest your food, for example.
We're entering the fermentation lab. This is where we use microbes like yeast and bacteria to make things that can help the environment.
Scientists have discovered that they can use yeast to make a biodegradable plastic, a plastic that won't be bad for the environment.
Today we want to get microbes to show how they can produce electricity.
So how do we know that this experiment is working?
We just touch this here. Now we challenge you. What other uses might there be for using microorganisms?
Think about your local environment. Think about your house. What if I could use a microbe to solve a problem?